Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about eigenvalues and eigenvectors. The lecture includes definition of eigenvalue and eigenvector, and we are going to find eigenvalue for a particular matrix and eigenvector of your matrix. And the last, the topic is arbitrary constant. These are the four definitions to find eigenvalue and eigenvector, arbitrary constant. These four topics will be included while solving the problems. Definition of eigenvalue and eigenvector. Let capital A equal to Aij be an n by n matrix. That is, this n by n represents number of rows and number of columns. Both are equal. That is the reason it is written n by n matrix. Here, Aij, I represents row, j represents column. A non-zero vector capital X. The meaning is capital X, it's not a zero vector. The meaning is it is not a zero vector. So you can see here, this is zero vector. But according to our definition, it is written non-zero vector. That means, this is non-zero vector. It is completely zero vector because it is a column matrix. Here, all the elements are zero. Here, according to our definition, compulsory capital X, it should not be a zero vector. It should be non-zero vector. That means like this type. It's said to be a characteristic vector of capital A if there exists a scalar lambda such that Ax equal to lambda x. This is the definition. Ax equal to lambda x. If Ax equal to lambda x where x is not equal to 0, the meaning is x is not a zero vector. That is, it should not be a zero vector. Compulsory, it should be a non-zero vector. X is an eigenvector or characteristic vector of A corresponding to the eigenvalue of capital A. That is our given matrix. Now, we are going to solve a problem. That is, find eigenvalue of the following matrix. Now, capital A is given 5, 4. The first row contains, this represents the first row. The elements are 5, 4. The second row, 1 and 2. The order of the matrix is 2 by 2. That is, 2 rows and 2 columns are there. Capital X equal to, it's a column matrix. That is, it is a column matrix. Column matrix means the matrix, it should have only one column. It has only one column, and so the order is 1 by 2. If it is only one column, we will call it as column matrix. So the given capital A, all the matrices are represented by capital letters, that is uppercase letters. Elements will be lowercase or real numbers or complex numbers. They are all called elements. Now, capital A is given, capital X is given. Solution. So, Ax, because we are finding AX, because the definition we know it, AX equal to lambda X. First we will find out AX. A matrix is written, X is written. We have to do the multiplication. That is, the first matrix, we will take the first row, which is multiplied by the second matrix. Here we will, first matrix we will concentrate row, second matrix we will concentrate column. So 5 into 4 plus 4 into 1. So you can see 5 into 4 plus 4 into 1, we got it. Next 1 into 4 plus 2 into 1, we got it. So 20 plus 4, we got 24, 4 plus 2, we got it, 6. In this 24 and 6, 6 is common, it has taken out the balance 4, 1. It's nothing but 4, 1. This column matrix, it's nothing but capital X, it is given in the question. So 6x. According to the definition, AX equal to what? Lambda X. Now AX equal to 6x. What we got it, that we put it here. So here lambda equal to 6. So we are doing the comparison. This both. So X, this lambda value is 6. So according to the definition, lambda is eigenvalue, capital X is eigenvector, capital A is given matrix. So the question is to find the eigenvalue. So we got it, lambda equal to 6. Eigenvalue is lambda equal to 6. Now, find eigenvalues. One more problem we are going to concentrate. Find eigenvalues and eigenvectors for the following matrix, capital A equal to, it is a 3 by 3 matrix. The order is 3 by 3 because 3 rows are there. 1, 2, 3. 3 rows and 3 columns are there. 3 columns are there. So 3 by 3 matrix is given. Before the problem, just now we did a small problem we discussed, in which capital A is given, capital X is given. Both are given. But in this problem, only capital A is given. So capital AX equal to lambda X. If lambda is the eigenvalue of the given matrix, that is our given problem, and capital X is the corresponding eigenvector, then by definition, A minus lambda I of X equal to 0. So A minus lambda I of X equal to 0. So now A, it is given in the question itself. Lambda, we wrote it as it is. And I, we know it. It is a unit matrix. And why here we selected the unit matrix order, particularly 3 by 3 we have taken, because here the given matrix is 3 by 3. If both the matrices order is same, then only it is possible for us to subtract. So keeping in that in our mind, we have taken here the unit matrix as 3 by 3. Then X is eigenvector, x1, x2, x3. Why here it is not written x4? It's not, because it's a 3 by 3 matrix, the given question. That is the reason 3. x1, x2, x3 it has taken. Suppose if it is 4 by 4 matrix, we will extend here x4. If it is 2 by 2 matrix, we will write x1 and x2 equal to 0 vector. Now, in this, just this it is copied as it is, minus also it is copied as it is, lambda we are taking inside, that is lambda into 1 lambda. We know it, lambda into anything, the multiplication, it is multiplied with 0, it is, we will be getting 0. So only the elements which lie on the principal diagonal. So lambda into 1 lambda, lambda into 1 lambda, lambda into 1 lambda. So x1, x2, x3 equal to 0 vector. So now it is the before slide only, it is this repeated. Now you can see. Now 1 here minus lambda, 1 minus lambda. This 2 minus 1, it is written as it is, because 2 minus 0, it won't affect, because 0, mathematics we know it, it is playing the role of additive identity. 0 is the additive identity. That is 2 minus 0, it will come the same value. Only the difference where the changes will be coming in the principal diagonal, the elements which lie on that. Now 2 minus lambda. Yes, here minus 2 minus lambda. Remaining all the elements you can notice here, 2 minus 1 and 0, 2 and 0, 0. So it is written as it is. Now the characteristic equation of capital A is determinant A minus lambda I equal to 0. This we have to keep it in your mind. Now, yes, these notations we have to keep it in our mind very, very strongly, because the entire eigenvalues and eigenvectors, these notations will play a role. First one, A minus lambda I, means it is characteristic matrix. If it is determinant A minus lambda I, that means this matrix, we are finding the determinant. Then we will get a polynomial in terms of lambda. If it is the determinant equal to 0, then we will call it as characteristic equation. That only here we have taken. Now, yes, the determinant equal to 0. So the determinant to find expanding, we have to do it. That is, this is R1, this entire thing. If it is like this, this is C1. Either we can expand by R1 way also we can do, otherwise C1 also we can do it, which will consume our timing here. If we expand by C1, our time will be consumed, because total among the 3 elements, 2 are zeros, so which save our time. Now you can see it here. This is the C1. Yeah, we know it. This we have taken. This part, the determinant. So if you are taking here 1 minus lambda, the particular row, particular column, we will neglect it. The rest, the elements only, we will do the cross multiplication. Expanded by, it is we are going to expand by C1. That is what this a green color, the rectangular box represents. Yes, the determinant, that is 2 minus lambda. This both we are going to do multiplication minus of. This mathematics we have to remember. So now this into this, yeah, it is written minus. This minus, formula minus. So very carefully the students, the negative signs comes. It represent, it is in the formula or it is in the problem. We have to be very careful. Now this into this, both it is multiplied, minus that is in the formula, and these two we have to multiply. 0 into 2, 0. So next, yeah, we multiplied it. 1 minus lambda equal to 0. So you can see here that is written. So minus lambda equal to, so it is coming here. So minus lambda equal to minus 1. So lambda equal to 1. Next, 2 minus lambda, that is this one, it has taken here. It has come here. 2 minus lambda equal to 0. So minus lambda equal to minus 2. Both the sides, the negative sign is cancelled. We are getting lambda equal to 2. The leftover is minus 2 minus lambda equal to 0. So minus lambda equal to, so the minus 2 also coming here. So it is becoming minus lambda equal to 2 equal to lambda equal to minus 2. This has come the sign here. So the lambda values, we got it 1, 2, minus 2. So we know lambda represents eigenvalue. So we got the eigenvalue for our given matrix A is 1, 2, minus 2. So we can see the eigenvalues are actually here, it is represented, that is lambda equal to 1, 2, minus 2. Now, when eigenvalue lambda equal to 1, what is the eigenvector? That we are going to find. A minus lambda I of x equal to 0. So this already in the before slide it is explained, that only here it is taken. Yes. Now lambda equal to 1. So here in this matrix, wherever lambda, we are going to put 1. The remaining elements will be same. So 2, minus 1, 0, 2, 0, 0. That as it is written. Only in the lambda place we are going to put 1. So we are putting 1, it is becoming 0. Here we substituted, we got it 1. Here we substituted, we got it minus 3. So you can see here, see this animation part, the green color, the rectangle or representing the lambda value substituting, we got these elements which lie on the principal diagonal 0, 1 and minus 3. So, yeah. Now, you can see here, this we have to do the multiplication. The multiplication first, we will given the matrix, the first matrix we will concentrate always row. The second matrix column. So 0 into x1. It is 0. That is the reason here it is not written. Next 2 into x2. 2x2 minus 1 into x3 minus x3. Next. So 0 into x1 it is not written. 1 into x2. Yes. 2 into x3. Next. Minus 3 into x3. So from the equation 3, so we know it, this is the equation 3, that is a minus 3x3 equal to 0. That is written, from which we are getting, that means the minus 2 coming this side, it is 0 by anything. Yes, we know it, 0. So x3 equal to 0. So with the help of these equations, now from the equation 3, we got the value x3 equal to 0. Now, our aim is to find the values of x1, x2, x3. Among the 3, we got it x3 value equal to 0. Yes. Now, substituting the value of x3 in equation 1. Yes. Now you can see this equation, this is our equation 1. So the equation 1 is written. In this, we are going to substitute the value of x3. x3 value, we know it is 0. So we substituted. So this x3 place we substituted 0. Then the balance we got it 2x2 equal to 0. So it's nothing but x2 equal to 0. So with the help of these equations, from the equation 3, the help we have taken x3 value, we got it x3 equal to 0. With the help of x3 value, we substituted in equation 1, we got it x2 equal to 0. One small doubt which will ring in our mind, why specifically we have to take equation 1, why we can't take equation 2? Yes, nothing wrong in it. We can take even equation 2 also. Now, yes, x3 we got it, x2 we got it. Now, the remaining one is x1. Yeah, we can see here from the above this 3 equation, it is impossible to get the value of x1 because that x1 only, it is not occurring at all here. Then how to find the value of x1? If the variable is there, we can. But the variable that x1, it is not at all there. Then how to find? But we have to find, which is impossible also to make it possible. That is mathematics. Here, to get the value of x1, we are going to arbitrary constant. That is, arbitrary constant, it's nothing but we can assign various values, but still it remains unaffected by the changes in the value of the variable. That is arbitrary constant. So x1, we are declaring arbitrary constant. We can assign any value to it, but not 0. So x1 equal to k we are declaring. K can take any value, 1, 2, 3, any value we can take. So now x1 we declared, that is arbitrary constant k, x2 0, x3 0. Now capital X is the eigenvector. So x1, x2, x3. So x1 arbitrary constant k, x2, x3 solving the equations we got it. This k value we are assuming 1 to save our time, or we don't want to make more complicated. Very simply we can take 1. So 1, 0, 0. But k equal to any value we can take, nothing wrong in it. But here it has taken 1. So when lambda equal to 1, we got the eigenvector, that is 1, 0, 0. 1, 0, 0 is the eigenvector when eigenvalue lambda equal to 1. Next, eigenvector corresponding to eigenvalue lambda equal to 2. So same, a minus lambda a, x equal to 0. That is how to read this part in the sense, the non-zero solution x of homogeneous system is the eigenvector corresponding to this eigenvalue of the given matrix A. That is the long sentence for this mathematical formulation. Now, this already we found it. Yes. Now, lambda, wherever lambda is there, we are going to substitute this. 2 we are going to substitute. So, you can see 1 minus lambda. Yes, lambda plus 2, it is substituted. So 1 minus 2 minus 1. 2 minus 2. Yes, it has become 0. Minus 2 minus 2 minus 4. So we can see this, this rectangled ones. So it is making our understanding level more. -1, 0, -4. These elements, we got it when lambda equal to 2, it's substituted in this matrix. Yes. Now we multiplied it already. So we have to take multiplication. The first matrix, row, we will concentrate. Second matrix, column. -1 into x1. Yes, minus x1. 2 into x1 plus 2x2. -1 into x3 minus x3. Next, 2 into, here, 0, 0. So x1, x2, it is not there. So 2 into x3, 2x3. The same, the last one also, 0, 0. First two elements are 0. The last one is -4 into x3. So -4 x3 equal to 0. We got 3 equations. So now, so the 3 equations are there. From the equation 3, we got it. That is -4 x3 equal to 0. So x3 equal to 0, we got it one value. Even if it is possible, we can take it even equation 2 also, nothing wrong in it. Yes, substituting the value of x3 in equation 1. So the equation 1 is written. In the equation 1, we are going to substitute the value of x3. We substituted. So x3, it's 0. So it is not written. So minus x1 plus 2x2 equal to 0. After substituting the value of x3, that is 0 in equation 1, we got this one. So x3, we got it. So now minus x1 plus 2x2 equal to 0. So minus x1 equal to, so we brought this side, it has become minus 2x2. Both the sides, negative sign is cancelled. We are getting x1 equal to 2x2. We got one relation, that is x1 is equal to twice into x2. Relation we got it. Whereas this is x3, value we got it. x3, the value is 0. Whereas we want the value, x1 is how much, x2 is what we wanted. But here we are getting the one relation we are getting. We don't want relation, we want the value. So, arbitrary constant we can declare. Where it is not possible, we can declare arbitrary constant. So, let x2 equal to arbitrary constant. Here the genuine doubt will be coming. Why we have to declare only x2? Why not x1? Yeah, we can declare even x1 also. Either x1 or x2. 1 we can declare. So, let x2 be the arbitrary constant. So, x2 we are taking as sub k. Substituting x2, we are getting, that is x2 place we substituted the value k. We got it x1 equal to 2k, we got it. So, x1 equal to 2k, x2 equal to k, arbitrary constant we have taken. With this help, this 2k, that is the value of x1, we got it. x3, from the equations, we got it. So, capital X, that is our eigenvector, x1, x2, x3, 2k, k, 0. So, simply k equal to 1, the value we will take. So, k place we substituted 1, 2, 1, 0. So, the eigenvector is 2, 1, 0 is the eigenvector when eigenvalue, that is lambda equal to 2. We got the 3 eigenvalues, that is 1, 2 and minus 2. 2 we completed, the leftover one is there, that is lambda equal to minus 2. So here a minus lambda I x equal to 0. Now that is a matrix. So lambda place we are going to substitute minus 2. So here we substituted 1 minus of minus 2. That is the reason 1 plus 2 we got it 3. 2 minus of minus 2. So we got it 2 plus 2 4. Minus 2 minus of minus 2. Minus 2 plus 2 it is becoming 0. Remaining other elements are written as it is. Now you can see the rectangled one. Yes, which is making our understanding level more. 3 4 0 we got it when lambda equal to minus 2. That is, we substituted in the place of lambda, we got this 3 4 0, the elements which are lying in the principal diagonal. Yes, so this is the matrix recently we got it. Then we are going to do the multiplication as usual, very simple one, this eigenvalues and eigenvectors. So the first row we have taken 3 into x1, 3 into x1, it is written here, 2 into x2, yes, 2x2 minus 1 into x3 minus x3. So we completed the first row, the work is over. Next we will take the second row, 0 into x1, that is the reason it is not written. 0 into anything, we know it is 0. 4 into x2, yes, 4x2, 2 into x3, 2x3, completely that third row is 0, so it 0 equal to 0. We got the 3 equations. So from equation 2, that is equation 2, that is 2x3 equal to minus 4x2. Here we can see it. Both the sides 2 is common, it is cancelled. So we are getting x3 equal to minus 2x2. We got it. Now here also we got one relation, we got it. That is x3 equal to minus 2x2. We are declaring x2 is the arbitrary constant. If we want, we can declare x3 also arbitrary constant, nothing wrong in it. Now x2 we are declaring, that is x2 equal to k. So next, we are substituting in the place of x2 k. We are getting minus 2 into k, got it, x3 equal to minus 2k, we got it. So x2 equal to k, substituting, we got it, x3 equal to minus 2k. So you can see these 3 equations, x2 and x3 values we are going to substitute because we want the values x1, x2, x3. x2 arbitrary constant we declared. With that help, we got it x3. The balance x1 is there. For that purpose, these 3 equations, we are taking the first equation, because in the first equation taking only x1 value it is there, x1 the variable it is there, which helps us to find out the value of x1. In this equation we are going to substitute the value of x2 and x3. So substitute 3x1, it is written as it is, that is plus 2, that is x2 is k, that is minus is written as it is, then x3 it's nothing but minus 2k. So it is simplifications only, 2k minus of minus plus 2k. So 2k plus 2k we got it 4k. So from which we got it, we obtained it minus 4k by 3. So you can see x1 equal to minus 4k by 3, x2 equal to k, x3 equal to minus 2k. In this one, we have taken the arbitrary constant. With this help, we got it x3 minus 2k. With these two help, we have got it x1. So x equal to x1, x2, x3. All the x1 value, x2, x3. All the values we substituted it. That is x1 is minus 4k by 3, x2 is k, x3 is minus 2k. K, we are taking the constant value as 1. Minus 4 by 3, k 1, minus 2 into 1, minus 2. So the vector minus 4 by 3, 1, minus 2 is the eigenvector when the eigenvalue, that is lambda equal to minus 2. So eigenvalues are 1, 2, minus 2. So when eigen is 1, we got this is the eigenvector, and when it is 2, when lambda equal to 2, we got the eigenvector 2, 1, 0, and if it is minus 2, we got it minus 4 by 3, 1, minus 2. So it is a very simple one to find, that is the eigenvalues and eigenvectors. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.